Welcome to a lesson with Dr. Powell. Let's look at transformations of the unit circle and interpret them as ellipses. X squared plus y squared is equal to 1. Now see how this is like an X box in here? This is like a Y box. Notice that neither of them is solved for. So they both kind of behave as something that's not solved for in a transformation. For instance, if we replace this X with X over 2, and this y with y over 4, then for x transformations, we do x over 2 and think what has to happen. We multiply by 2. For y's, we do the exact same since it's not solved for. So we notice that all the x values are multiplied by 2 and all the y values are multiplied by 2. Let's look at our parent graph. It's a circle with radius 1. So now all the x values in the circle are now multiplied by 2. So this 1 is now stretched out. This one is stretched out that way to 2 and negative 2. What about the y values? All the y values multiplied by 4. So this 1 now goes all the way to 2, 3, 4. And similarly, this one goes way up there. The effect is to get an ellipse. Let's draw it down here again. So we're going to have from negative 2 to 2 and from negative 4 to 4, we're going to have an ellipse. So naturally, this right here, we can graph right there as an ellipse. Now, oftentimes, the equation of ellipse isn't given that way. Perhaps it's given like this: x squared over 4 plus y squared over 16 is equal to 1. Could we still interpret it the same way as what we had before? Notice that this square doesn't apply to the whole thing here, doesn't apply to the 4. However, we could rewrite this as x over 2 quantity squared, and then it would. Notice that these two guys are the same. Take this 2 distributes the 2 to be 4, 2x squared. This is often the way it's written instead of this. However, thinking about it this way, we know how far to go in the x direction. And similarly over here for y. This would be y over 4 quantity squared. Simply, if it's written in this way, which is called the standard form for the equation of ellipse right here, then this part, we take the square root of it. That's how we get to there. This part, we take the square root of it. That's how we get to there. It's kind of like we're making a box into which to put the ellipse. Here, you see this 4, we take its square root to be 2. So we know we're going to be making a box. In the x direction, we go this way 2 and that way 2. In the y direction, we go this way 2, 3, 4, and we go down the other way 2, 3, 4, down 4. Then we have a box in which to put our ellipse. Now, what if we have something like this? X minus 3 squared all over 25 plus y plus 1 squared all over 9. Then we set this equal to 1. So this is the equation of an ellipse, or a transformation of x squared plus y squared is equal to 1. Now, how is it a transformation? Let's think. If we take a square root of 25, that would be like a 5 here, x minus 3 quantity squared. So this would be like your x box. Plus, and then this would be like y plus 1 all over 3, like your y box here, is equal to 1. So transformation time, trying to whittle this to x here. We multiply it by 5. And then the last thing we do is we add 3. And here we multiply by 3. And then we subtract 1. See this 3 and this minus 1. 3 is what makes this guy 0. -1 is what makes this part 0. Essentially, that's where the origin is moved. Because think about what the origin is doing. First, you multiply the origin by 5, the x value by 5, the y value by 3. It's still the origin when you do your stretching in other direction. It's like we're looking at x squared over 25 plus y squared over 9, where we're stretching in 5 and 3. So from the origin, it's like in the x direction, you go 5, -5, y direction, you go up 3, -3. And then right here, you see this 3, -1. That's really just the coordinates of the new center of the ellipse. So we've moved in the x direction 3 and the y direction down 1. So really what we can do in our picture is just label, just kind of maybe make these dotted lines. And then just label this point as 3, -1. And then just draw the ellipse around it. So, and it fits in this box right here. So we just have a couple things to remember. When we have something like x -1 squared over 49 plus y plus 2 squared over 16 is equal to 1. Right here, we know we're going to go from the center in the x direction, 7. And in the y direction, we're going to be going up 4, just the square root of 16. So square root of 49 is 7, square root of 16 is 4. So 4 down 4. And then the center is given what makes this 0, 1, what makes this 0, -2. So the center is actually 1, -2. We have a box which the ellipse sits in. And we can just draw the ellipse inside. And then we've successfully graphed an ellipse from standard form. Thanks for watching.